Okay, everyone, almost midday, but we're going to get going in a few minutes. Again, we're going to start maybe 1 or 2 minutes late, just because digital things being what they are, often people can't log in, but hopefully we'll have no issues. And Jose is here, I am here, I'm Paul Siegel, and we really appreciate your time. Look forward to a very good session. I will do a 2 to 3 minute quick introduction. And then Jose will take over. If you have questions and comments, please, we're just going to mute the line just so there's a lot of people that will be coming on. But please text them and we'll be able to track those, and Jose will be able to answer them as he goes along or as he has at the end of the program, as he can at the end of the program. So I probably will give it 2 more minutes just so people start coming in. And for those who are just arriving, I'll point out that if you look in your right text box, you'll be able to ask questions, and also if you complete a survey at the end of this program, you will get access to one of our 5-star free courses, or courses that will be free to you. Just let us know which ones you want. There'll be a selection of about 17 different courses. So, okay, 1 more minute, and I will start. And then I will pass it over to Jose, as I mentioned. Okay, good afternoon, everyone. My name is Paul Siegel, and I'm with Starweaver, and we have today a presentation. It's an introduction to Python. We have as our subject matter expert and Jose Portilla, who has been in the field quite a while. We'll tell you about him. He will tell you about himself in a moment. I will spend about 1.5 minutes, 2 minutes quickly running through some information for you that might be useful. Number one, we are a company that does corporate education in the IT, project management, and finance space. So you'll see a lot of IT companies and financial institutions as clients. We work globally and have been around doing this for about 16 years. We do both live and in-person courses. Those are the typical ones you might imagine. They're interactive, they're hands-on, they're practitioner-led. People like Jose, who have done the programs, and in fact Jose, as well as we have a online library of courses that you can do as self-paced. In this case, we are focusing on IT, but also there are other subjects and areas that we cover. 100% of what we do is so-called private courses, so it is not, and to corporations, so we don't really sell this to the consumer. But if you do have an interest as a team, please let us know. We'll be glad to help you out. We have some upcoming programs. This is the introduction to Python. There's an R in statistics program a week from today. And then about a few days later, there's going to be a Docker and Kubernetes program. Again, if you've signed up for this, you'll hear about these as well. There's an IDLE program on Internet of Things, and then best practices frameworks, including TOGAF and others that's coming up. And again, just keep coming back to our site, and you'll see those listed there. As a bonus for your participation, as I briefly mentioned for those who arrived earlier, there are 1 of 17 courses that you're going to be able to access for free. Here's a quick list of them, because again, you'll see a lot of IT and finance-related courses. I will re-text that on the side if that's a word. But if you look in your right panel in the chat box, you should see a link. So by the end of the program, please go there if you want to get access to your to the free course. And obviously, we're looking for your feedback to help us always improve what we do. With that, I will pass this now over to Jose. Just got to find his name on the list here, and he will be able to take you through the presentation. Thank you very much for your time. And again, if you have any questions or if you have any questions or comments, please just put them in the side. We'll be happy to address them as we go along. So Jose, you should be made the presenter now, and hopefully you should be able to speak as well.
Can you hear me? Can you hear me, Paul? Can you hear me? Hello?
I can hear you.
Oh, okay, I see. All right, awesome. And then hopefully you can see my slides as well.
Jose, are you speaking? I can't hear you, maybe just my phone, but...
If it loads up. Yeah, I'm speaking. I heard someone say they could hear me. I don't know if there's any way you guys can confirm. Not. I hear something else going on now. I hear a vacuum cleaner. Can everyone hear me? Maybe type into the chat box. Okay, I can hear some people saying, hear me. Oh, you still can't hear me? I hear some noise.
Jose, I can see your screen perfectly well. Everyone else can hear apparently, so go ahead. I may just be the laggard. Please go ahead.
All right, I'll start. Let's do this. Okay, well, welcome everybody. Just gonna briefly talk to you about Python. There's a lot going on in Python, so definitely can't cover everything, but hopefully give you a bird's eye view so you can know a little bit more about it. So we'll talk about just a brief introduction, give a little bit of a history of Python, overview of Python, benefits of Python, and then the most important part of Python, all the libraries. We'll go ahead and discuss those. We'll talk a little bit about what Jupyter Notebooks are and other IDEs, and then also discuss Django, Flask, and have a Q&A at the end. So I can't see the questions and answers right now, but go ahead and just type them into the box, and then at the end I can check those out and answer any questions you have. So just as a brief introduction, my name is Jose Portilla. I'm the head of data science at Perry & Data Inc., and I'm an instructor and trainer for programming and data science. So usually when I teach Python, it's in terms of things such as financial analysis or data science. So let's talk about just a very brief history of Python. Python's an open source scripting language, which is nice because that means you don't have to pay for it. And it was developed by a man named Guido van Rossum. He worked at Google initially and then now works at Dropbox. And it was developed by him in the 1990s. It was named after the Monty Python comedy group, which he was a big fan of, which is how it gets its name. And it's currently on version 3.5 and 2.7. And if you want to get the official documentation or information, the official website is www.python.org. So basically, there are these two versions of Python, the 2.7 and 3.5, and actually 3.6 is going to be coming out. A lot of times for beginners, there's some confusion as far as what are the differences between 2.7 and 3.5. Basically what happened in a historical context, Python was being developed in this 2.x versioning system, and there were some changes that would have broken 2. Since they wanted to make those changes, they basically made a new branch off and called it 3, and currently everyone, if you're developing a new project or just learning off Python, you should technically be learning 3, but to make it clear, these two versions are actually extremely similar to each other. There's very few differences as far as what's going on to a user. Under the hood, there's more changes going on, but to someone who's just learning how to program or learning how to use Python, they're very similar. So don't let that confuse you as far as what version you should learn. If you're just learning off, you should learn 3.5 or 3.6, which is going to be coming out soon, but they're so similar that if you know one, you basically already know the other. So let's talk about who uses Python. This is just a very short list of a ton of people that use Python. All the major companies probably in the tech sector use Python. Companies such as Yahoo, Google, Facebook, Disney Animation, NASA's a big Python user, Red Hat, IBM, and many, many more. Sites such as Reddit are run on Python, and their sources actually, or their source code is all open source. So if you want to figure out more of how to use Python at reddit.com, you can actually go to their GitHub repository and see all their code, which is interesting. So let's talk about why you would choose Python. So Python has a huge standard library, and what that means is it already has what's known as, in other languages, batteries included. And basically what that means is even in the standard library, you have things such as a mathematics library, things to do calculations such as sine or cosine. So that's already built into Python. Things like how to read a text file. All these packages are included in the standard library. And what's really nice about this is there's really nice quality documentation for the standard library. So if you ever want to look something up, you don't have to be Googling or looking at Stack Overflow for a long time. You can just go to the documentation, and it's all pretty well laid out for you there. And on top of just the standard library, which is the phrase that people use, the batteries included, that has all these packages for you, there's actually a ton of third-party modules as well. So if you want to do something with Python, more likely than not, someone else has already tried to do this and has open sourced a package to do it. So that can be anything from working with Excel files with Python, automating PowerPoints with Python, sending emails with Python. All of those kind of things are available to you as third-party modules that you can download for free. There's also an emphasis on code readability, and that's probably one of Python's biggest strengths. Python makes use of something called white space. In other languages, a lot of times you're using brackets to hold code blocks together, but Python is really unique in that it uses indentation and white space to make sure your code's organized. And if you don't have this organization, your code just won't run. So that really pushes you to write really readable code. And that saves a lot of development time. So developers' time is usually much more expensive than computational time. It's really easy to just buy a new computer. It's not so easy to hire a whole new developer. So the fact that Python really reduces development time is really great. And there's a broad range of uses for Python, as I mentioned, anything from like a little shell script to entire enterprise web applications to scientific uses. And the best part of all, it's very easy to learn really quickly. And I personally think that actually the Python community, as an open source community, has one of the best and most welcoming communities online. So if you ever feel lost, everyone's really open on the forums and online, ready to help you out. And I think that stems mostly from this last bullet point, that it's really easy for beginners to pick up. So a lot of the Python community still remembers how it was as a beginner and is more than willing to help you out. So it's a very friendly community compared to other languages, which is a big bonus. So let's talk about Python performance, which is a lot of times what some people try to get on top of Python for. So it can't run as fast as something like C++, and since it's an interpreted language. However, you should know that there are a lot of libraries for Python that are written to have direct bindings to C or even Fortran, which are languages that run really, really fast. So you can take advantage of these specific libraries, and we'll show you one later on called Numpy, that saves a lot of developer time, and it's usually, again, much more valuable than computation time. So what you can do is actually harness and leverage the power of Python's quick scripting ability, use one of these libraries, and have it bind to either C or Fortran to run your operations almost as fast as if you had taken all the time to write in some of these original faster languages. So let's talk about some Python libraries. So Python has hundreds of third-party open source libraries, and we're going to discuss some of the most useful and popular ones. And this is not an exhaustive list. There are a ton of these. These are just some of my favorites that hopefully are the most obvious for what use cases you may find. So Numpy is the one I actually was just talking about. So Numpy is officially known as a package for scientific computing with Python. It has this powerful n-dimensional array object, really sophisticated broadcasting functions, and most importantly, it has tools for integrating C, C++, and Fortran code. So it runs extremely fast. Python, since it's an interpreted language, usually runs a little slower than some of these other languages, but if you just use these NumPy packages, it can run almost the same speed as some of these extremely fast languages. Now this is mostly for scientific computing, so it also includes things such as linear algebra, Fourier transforms, random number capabilities, etc. And this is on top of Python's own mathematics standard library packaging. Then one of my favorite packages is called Pandas. And Pandas is basically the Excel for Python. It's a really, really useful library. So Pandas is an open source library providing high performance, easy to use data structures and data analysis tools for the Python programming language. And you can think of it as similar to the R programming languages or a very powerful version of Excel with added functionality. And whoops, sorry. Basically, Pandas allows you to open up Excel files, CSV files, TSV, connect with a SQL database, any sort of tabular data format. Pandas is a library that can open that up for you. But what's really nice about Pandas and what makes it so powerful is you have the capability of Pandas to open files that would usually be too big for Excel to open. So if you have a 4 GB CSV file, something like that would usually crash Excel depending on how much RAM you have on your computer. But Pandas can open that up no problem. And there's even additional libraries for Pandas, such as Dask, which allow you to open up files that are larger than memory and RAM. So it will actually break them up into convenient sizes, and you can then just iterate over those chunks, essentially. So if you have some 20 GB file that for some reason is not in a SQL database, you just have it on your computer and you're trying to figure out how to open it, how to do calculations on it. Pandas, with some additional libraries, actually has the capability to break that up into chunks and then just iterate over those chunks. There's no other program really that would be able to open up a file like that that's larger than your actual RAM. And if you're familiar with the R programming language, you can basically think of it as Pandas is R for Python. It's a really useful library. Was invented by this guy called Wes McKinney for financial analysis. Pandas, since it was built for the financial industry, has the capabilities to read stock information directly off a Google or Yahoo API. Really, really powerful tool and one of my favorites. And it's built off of Numpy, so it runs just as fast as all that Numpy stuff. Data visualization is also one of Python's huge strengths. Python plotting. Python has a ton of plotting libraries. There's things such as matplotlib for static plots. That was created by John Hunter, who, if you've ever heard of a language called MATLAB, he basically wanted to create MATLAB's visualization capabilities for Python. So what he ended up doing was creating this library called matplotlib, free, open source, and you can create static plots with matplotlib. And if you might be sensing a theme that basically a lot of Python developers want something that's available in another language, they just end up building it in Python and then open sourcing it and making it available to everyone. So you can take advantage of all their hard work and look like a genius for it, which is nice. Seaborn is another library for plotting. It focuses more on statistical visualizations, really pretty looking plots and graphs. And then you can have Plotly, which is a open source library for cross-platform interactive visualization, which is really awesome. Basically, you can create a visualization in Python and set it up as an HTML file or export it to Excel or MATLAB or R using this Plotly library. It's cross-platform. It's interactive, which means you can do really cool stuff like have your mouse over points and then it'll report back information, do geographical plotting. Really powerful library, really awesome stuff going on there. So let's talk about web development with Python. So there's basically two web development frameworks. There's Django and there's Flask. So Django is probably the more popular one. It's a high-level Python web framework that encourages rapid development and clean, pragmatic design. It's very fast, and really important, security is a high priority. So even though it's open source, security is something that's very important to Django. So if you ever feel uncomfortable using something that's open source as a web framework, Django is extremely popular. It's used by a ton of websites, things such as, I believe Pinterest still might run on Django, or at least use it in the past. And it's also very scalable. So Django has all the tools you need if you want to ever do web development and build a website that runs on Python. So you can take advantage of that fast development time of Django and Python. And then, sorry, whoops. And then Flask is basically, you can think of it almost like a little brother to Django. It's what's known as a micro framework. So it doesn't include all the bells and whistles of Django, but if you ever want to build your own maybe blog or something or mini site, Flask is a nice alternative to that. So let's talk about big data APIs. So Python is getting more and more popular as an API for a lot of these big data technologies that are coming out. So Python has APIs for many libraries. Spark and Hadoop both have APIs for Python. So if you ever dealt with big data, you've probably heard of Hadoop as a distributed system, and you've probably heard of Spark since it runs about 100 times faster than Hadoop. And there's also MySQL, PostgreSQL, etc. All these SQL databases and all these SQL engines have API libraries for Python. And Python's become this really big player in not just data science, but data engineering because of all these APIs and all these connections to a lot of these big data libraries, or even just more, I guess, normal SQL type databases. But what this allows you to do is it allows you to quickly prototype data applications with Python and not have to deal with the frustrations of some of these original languages, such as Hadoop or Spark, or sometimes, since they're not written in Python to begin with, they can be sometimes hard to work with, but you can use your Python API in order to quickly develop applications with these technologies in Python. So really powerful stuff there, and you basically get the best of both worlds: fast development time and then the power of these new big data technologies. All right, so that was just a kind of very brief overview. I'll open it up to questions and answers. Well, questions and the answers. And I'll leave my LinkedIn profile there if you guys want to connect. But let me click escape here and go back to you guys, see if we have any questions. Hopefully you can still hear me. Can everyone hear me? How's it going? Hello? Oh. Can I describe some scenarios in which Python is optimal? So in my opinion, Python is optimal for in the field of data science, and I think a lot of people agree. R is the other big contender there, so is MATLAB, but Python has really taken off. So a really optimal situation is where you need to take in data from some other language or some other database, such as Spark, SQL, Hadoop, and this is why Python is also sometimes known as a glue language. It basically glues a lot of these applications together. So it's optimal when you need to connect systems to communicate with each other. So if you need to connect your website to a database, you can use something like Django or Flask to do that easily. If you need to connect your SQL database to some sort of visualization dashboard, Python is a great tool. It has libraries to connect to your database, and then it has the fantastic visualization libraries. So it's got a lot of capabilities for connecting things together. Can I show you some examples? I can show you, let's see. Sure. Well, I can also show you some, let's see, let me go to my, hopefully this loads up. I'm trying to load up some notebooks for you guys right now, just so maybe we can see what this may look like. So my internet might be a little slow right now because of the go-to meeting. But here we go. So I'm just going to show you maybe like a very simple example of what you can possibly do with something like Python. So these are some notebooks I've created for things such as machine learning, which is also hugely popular with Python. Python has a package called scikit-learn, which is probably one of the most popular machine learning libraries in the world, and it's written all for Python. And so here's an example of what you can do with something like Python. Here I have a notebook with some explanation, which I use usually when I'm teaching. But we can see here that this is kind of a visualization done with Python, and it took, I don't know, like 6 lines of code. all these codes are also comments here. So there's some really nice stuff. And here, this is what Pandas looks like. You can see it almost looks like an Excel file, except you have a lot more power there as far as what it can do. And this is basically just a logistic regression, some sort of classification analysis. Here's some more visualizations that you can check out, data preparation, and then some mathematics there. So that's an example of what you can do with Python. Linear regression. You can see that these cells that actually have the code, there's hardly any code in there. That's because Python makes it really easy to do complicated tasks in just a few lines of code. So here I'm doing a whole histogram, which is like 3 lines. And again, you can see here 3 lines to make this scatter plot. And you can customize these. You can see here there's more Pandas stuff, linear regression models, and just a simple 1-line call. So a lot of the hard and heavy lifting has already been done for you and set up in a way where you can take advantage of all these libraries put together. So you spend a lot less time developing and more time actually doing the work that matters. So these are just some examples of what you can do with Python. And this is a more complicated script. So you can see that it can also handle larger tasks to do more complicated things, such as stepwise visualizations or random forest, which is another machine learning algorithm. And here we can see we're trying to predict, I believe, some stock pricing. All right. Hopefully that gave you an idea of what this kind of stuff can look like. Does anyone have any other questions? What is the maximum size of data set to be used in Python, or is there no logical maximum? So if there is no technical maximum, basically that's more defined as far as where your data is being stored. So a library like Pandas, which is the one I've been kind of showing off, usually that would max out by the size of the RAM on your computer. So if you had 16 gigabytes of RAM, maximum size would be 16 gigabytes. However, you can download additional packages such as Dask, which allow you to split things up in memory. So basically, then you can do essentially whatever your hard drive can hold. But after a certain amount of time, maybe if you're going like 50 to 100 gigabytes, it really doesn't make sense to hold it as a single file anymore. In that case, you're probably using something like a SQL database, like a Microsoft SQL Server kind of situation. And in that case, you would hold it in a SQL database, and then Python can just draw it out in chunks. I hear that codeacademy.org is the best way for a beginner to start. Is this true? What is your impression of Code Academy? I'm actually not a big fan of Code Academy. I think Code Academy is more if you want to learn syntax, not if you actually want to learn how to program. Yeah, sorry to kind of, I don't know, trash Code Academy, but I've always been disappointed by Code Academy's ability for people that are just starting to program. I personally teach on a website called Udemy, so that's what I recommend to people more than Code Academy. But it really depends what your experience is as far as choosing a platform that feels right to you. Any other questions? I am from a mainframe background. Yeah, sorry, someone just sent to make you the presenter. I think, Paul, you have the power to do that? To make someone else presenter?
I do have the power.
I'm from mainframe background. Can you use Python like COBOL? Connecting database, run large. Sorry, did someone say something?
No, go ahead.
Oh, you know, I would have to look into something like COBOL. That's pretty old, but I'm sure someone out there has done some sort of glue API to connect stuff like that. But Python itself can connect to a database and run queries itself. There's a lot of APIs and packages for Python to connect to databases, SQL databases of all sorts of kinds.
James, I just would like, I was texting you, messaging James, who just asked to be the presenter, just questioning what you would like to do, what like to present. If you just text me back, I'm happy to make you the presenter if you want to show something in particular. And I will say, just as Paul again, Jose's courses on Udemy are quite impressive, and they're, tens of thousands of people who are signed up for them, so I highly recommend them. They're quite good. If you get into a deep dive course with Jose, again, the same kind of things are quite impressive. I think that the idea, in part, has been when we've done programs, sometimes it's to taste test, what I call taste test, the kind of platform that Python is and the various components that Jose's been talking about to see if it would work in your environment. So whether it's enterprise or team level, you can test that out and then to see if it might work. And then ultimately as well, we've done programs where people taste test and then they realize this is a tool that would work for them, but just needs to, but people need to understand more about it. So again, I'm asking James what he would like to present, or if there's anyone else has other questions.
Hit the wrong button. Sorry about that.
Is there a difference in performance? Suppose we're connecting to multiple databases between R and Python. Not a huge difference in performance. Like one isn't going to be much faster than the other. But I believe Python, much more than R, has the ability for optimization. So there's also a lot of packages. One is called Numpy for Python, that if you really, really need something to go extremely fast, Python's already usually fast enough for the majority of use cases. Unless your specific application is built for the purpose of being extremely fast, Python is usually, the performance of it is more than enough to handle any normal applications. It's only like if you're trying to build the next Uber or something, or Google, where you'd have to start looking into other tools. But at that point, you have to construct your own tools in-house just because no one can scale at that level. But for like the majority of applications, I've never had any issues with Python being performance-wise not good enough, if that answers your question.
Okay, so it seems like we've covered the topics very quickly and effectively. Don't really know what James was looking to talk about or present, but again, I will text into the side window the feedback link, and also obviously if you complete the survey, the link will get you access to one of those 15 or 17 courses. So you should either be able to copy it or click on it, I believe. If not, just cut and paste. Really appreciate everyone's time today, and thank you. We're looking for both feedback and in terms of course subjects and how this was covered. Oh, there's another question. Data visualization.
Yeah. One last question here. What about, okay, what about data visualization via R and Python? So if you're familiar with R, which I feel like you are, no pun intended, you're probably familiar with ggplot. So there's two really great things for that. Python actually has its own version of ggplot. So if you are familiar with ggplot and you like ggplot, you can basically take all that skill set and transfer it straight to Python using Python's version of the ggplot library. And as I mentioned, those Pandas data frames are basically like R for Python. So our users, especially for data visualization, have no problem jumping to Python. So data visualization, if you're familiar with R's ggplot, there's basically another library. It's also called ggplot. But it's for Python, and it's fantastic. Now that being said, I believe there's even better alternatives to R's ggplot or Python ggplot, and Plotly is one of those. So like I mentioned with Plotly, it's cross-platform. So if you wanted to develop a visualization in Plotly, you could then export it to R or Excel or even JavaScript. So I think data visualization is one of Python's strongest suits, more than any other language, including R. And I know R, is held on a pedestal for those capabilities, but Python is really fantastic for that kind of thing. Any other questions? No problem.